Continuing on with Unit 3, and we are in Learning Target 3B, Interval Notation and Compound Inequalities. By the end of this lesson, you will be able to write an inequality in interval notation, change from interval notation to a graph and/or to an inequality, and solve compound inequalities and graph their solution set. So before we get into compound inequalities, we're going to talk about what interval notation is. So we can use interval notation to describe an interval on the number line, and we end up doing this by using three symbols. So we use parentheses, brackets, and infinities. We also will be using numbers, but these are kind of some symbols that we end up using, so let's talk about what the symbols mean. So parentheses, we use these to indicate that the interval's endpoints are not included. So we use these parentheses when we want the endpoints to not be included. We would use parentheses then when we have a less than or a greater than inequality. This is also equivalent to those open circles on a number line because we are not including the endpoints. On the flip side, brackets are used to indicate when the interval's endpoints are included. And those would have to be with when we have less than or equal to or greater than or equal to inequality signs. And we use these then with our closed circles if we were looking at it from a graph perspective. Now, infinity is used when the interval continues forever in a certain direction. We use positive infinity when the interval continues forever in the positive direction. And then we'd use negative infinity when the interval continues forever in the negative direction. And one thing that I forgot to add in here, which is extremely important, is that we always use parentheses with our infinities. Either positive infinity or negative infinity, we will close that off with a parenthesis. We will never use a bracket, and the reasoning behind that is we never technically reach infinity. Infinity is not a number, so as this continues forever and ever, it wouldn't make sense to put a bracket on it because a bracket is saying, oh, that's where I'm stopping, but we keep going on forever and ever in a direction. We will use these three concepts of parentheses, brackets, and infinity and write our interval notation. The way interval notation looks on the side is it kind of looks like a coordinate pair. So we have some number that we fill in here, comma, maybe another number, and then we could have parentheses, maybe we have a bracket on one side. These are different combinations that we could create for interval notation. But interval notation itself looks like a start to an endpoint with either parentheses or brackets depending on what type of inequality we have. Let's look at a couple examples here from graphs. So in the first example, we are given a graph. So we have 2 with an open circle at it, and all the shading is to the right-hand side in our first example. If I'm going to translate this into an inequality, because they are asking us to, given the graph, state the inequality and the interval notation, let's start with the inequality. So for the inequality, I need a variable. I'm going to use x, and we're saying that we're taking everything that is bigger than 2, so x is greater than 2, and because I have an open circle, I will not put an equals to sign. So the inequality that matches this graph would be x is greater than 2. Now the interval notation is going to look like kind of like a coordinate pair. I'm going from 2 would be my starting point, comma, because I keep going forever and ever in the positive direction, this is going all the way to infinity. Now what I have to decide is, do I put parentheses or brackets? And each of those is an independent decision. So whatever I do on the left-hand side does not affect whatever I put on the right-hand side. So on the left-hand side at 2, what I want to pay attention to is this an open or a closed circle? This is an open circle, so I would put a parenthesis here because I am not including the endpoint, which is also why in our inequality we had x is greater than 2. On the right side for infinity, we always put a parenthesis because we never technically including it. So this right here would be our interval notation. So we can kind of see how it looks like a coordinate pair because it's something comma something else, but it's really representing an interval along a number line. So I'm going from 2 all the way to infinity, not including my starting point of 2 since there is an open circle there. and then this over here just to make sure we know this is our inequality. So we answered both parts of the question, the inequality and the interval notation. Okay, let's look at our second example. So in this one, we're given a graph where I have a closed circle or a filled in circle at 4, and all of the shading is to the left-hand side. So let's start with our inequality. So for our inequality, I need a variable, so I'm going to use x again. It technically doesn't matter what variable we use. And this graph where everything that is to the left of 4 or everything that is less than 4, and because I have a closed circle, I want that equals 2 bar. So the inequality for this number line and this graph would say x is less than or equal to 4. When we do interval notation for it, we have to think about, well, where am I kind of starting and where am I finishing? Well, this keeps going all the way, it keeps shading all the way to the left-hand side. So we're really kind of starting at negative infinity since there's no other place where it stops, and it's going up until 4. So my smallest to my biggest. So just like we would write on a number line, we go smallest to biggest from left to right. Which is why on the first example I went 2 to positive infinity because 2 is the smallest value all the way up. Versus in example B here, we're going smallest, which is this negative infinity concept, all the way up to 4, which is our biggest number. Now we have to think about, well, do I put a parenthesis or bracket? Well, on negative infinity, we will always be putting a parenthesis because we never technically reach it. Infinity is not a number, it's a concept, so that's why we have our parenthesis. On 4, though, because I have a closed circle, I have to make sure I'm including it, so I want to put a bracket on 4 because that specifies that I am including the endpoint, which also matches up with our less than or equals to bar that we have on our inequality. So the second one here is our interval notation. So as we can see from these first two examples, we're not really solving for anything here. Interval notation is just another way to describe a solution set. And as you take more math classes and you get further and further, interval notation tends to get used a little bit more often than inequalities because it's just kind of convenient in terms of the problem's context. So it's important, and what this section is really focusing on is how do I go between those three concepts? How do I go from a graph on a number line to an inequality to interval notation and back to any other one? So we have to make sure that we're fluent in being able to kind of transfer between the three different notations of the graph, the inequality, and the interval notation. Okay, we have two more examples that have these same instructions here. So given the graph, state the inequality and the interval notation. Why don't you guys pause the video and do example C on your own first? So make sure you are stating both the inequality and the interval notation. So pause the video and try that on your own first. Okay, let's check example C. So I'm going to start with our inequality. So I need a variable. I'm going to just keep using x. So on our graph, we have a closed circle at -10, and then it's shaded all the way to the right. So that means everything on the bigger side of it, so x is greater than, and in this case equals to, because of the closed circle, -10. So that inequality is saying everything that is greater than or equal to -10, which lines up with the closed circle at -10, everything shaded to the right-hand side. Interval notation, it's starting at -10 and going all the way to infinity, since -10 is the smallest, all the way up to infinity on the right-hand side. At -10, I'll make sure I want to have a bracket there because I'm including that endpoint, and then I'll put a parenthesis on infinity by definition. Okay, why don't you guys pause the video and do example D on your own first, and then we'll check it together. Okay, let's check part D. Let's start with our inequality answer, since I'm getting asked for two different things. So for our inequality, I need my variable, so I'm going to use x again. On this graph, we have 0 with an open circle, and we are shaded to the left-hand side. So in this inequality, x is less than, because it's everything to the left, less than 0. And I don't put an equals to bar because there is no filled in circle at 0. Meaning I don't want to include 0, but I want to get infinitely close to 0. So everything x is less than 0. In our interval notation, I have to think about how can I represent this as a interval now. So my smallest value is this negative infinity all the way up to 0. So I'm going negative infinity, comma 0. Remember, we always put parentheses with our infinities, and then at 0, I don't want to include the endpoint since there's an open circle, so I want to match that with an open parenthesis or a parenthesis. Okay, let's look at 2 more graphs. So in example 2 here, we can see that we kind of have graphs that look different than our prior 4 examples. So in each of these it says, given the graph, just state the interval notation. So we're not going to worry about the inequality right now because we actually haven't talked about those inequalities yet, and we will in a little bit, but let's just focus in on the interval notation here. So for our interval notation on this first graph, let's see what's going on. We have an open circle at -2. We are then shaded to the right, but then it stops at 1 with a closed circle. So this graph is actually bounded by 2 finite numbers here. So I'm not going off to the right all the way or off to the left. I'm instead bounded, or I'm sandwiched in between our -2 and our 1. So in our interval notation, I'm going to want to start with -2, and I'm going all the way until 1. At -2, will I have a parenthesis or a bracket? I will have a bracket, or I'm sorry, I will have a parenthesis. I drew a parenthesis, but I said the wrong word. I will have a parenthesis at -2 because of the open circle. And then what about at 1? Will we have a parenthesis or a bracket? At 1, we will have a bracket because I'm including the endpoint, which is why I have the closed filled in circle. That will be our interval notation for our graph in 2a. Now let's look at the graph in 2b. So 2b kind of looks like they took 2 of the examples from 1 and put them together on a number line. And that's actually exactly what happened. So our interval notation here, because I have 2 parts of this graph, have to match that. What that means then is I'm going to have 2 separate interval notations as my final answer. So we'll do this one portion at a time. So let's start with the part on the left. So on the left-hand side, I'm going from -infinity all the way to 3, and then it stops. I will have a parenthesis at -infinity because of definition. I never want to include infinity. Then what will happen at 3? Will I have a parenthesis or a bracket? At 3, we will have a bracket because of the filled in circle and the fact that I want to include that endpoint. So this is our interval notation for the first part of the graph here on the left. Now we need to find our interval notation for the graph on the right. So the portion on the right starts at 5 and goes all the way to infinity. At 5, will I have a parenthesis or a bracket? We will have a parenthesis because we do not want to include the endpoint. And at infinity, will I have a parenthesis or a bracket? We will have a parenthesis. By definition, we always use a parenthesis on infinity. I'm going to join these answers together with the word or. And the reason I'm using the word or is because it would not be possible to be over here, which is smaller than 3, and bigger than 5 at the same time. So as I'm choosing these answers, I'm either on the left part of the graph or I'm on the right part of the graph. And if we were to use the word and, that would imply that I can be less than 3 and bigger than 5 at the same time, which is not possible. So that's why we're using the word or to join those together. These last 2 graphs actually lead us into what compound inequalities are. So in these 2 examples, they were each dealing with a compound inequality. So a compound inequality consists of 2 distinct inequalities joined by the word and or by the word or. So in our first example, this is actually what we call an and compound inequality. And I'll explain that in a second. Our second graph here, as we talked about, is what we call an OR inequality. So the reason the first one is an AND is because I can be both less than 1 and bigger than -2 at the same time. So it is possible to be bigger than -2 and less than 1. Because I can be both of them at the same time, we usually write it as one inequality. So in our example down here below our definition, this first example is an AND because I have x sandwiched in between -10 and 12. So because of this sandwiched in between it, this is an AND statement because x is both less than 12 and bigger than -10 at the same time. If I were to graph this, what I would get is I would have -10 on the left, I would have 12 on the right. If we switch colors here, think about this. Would you have an open or a closed circle at -10? We would have an open circle at -10 because there's no equal to bar, versus at 12 we're going to have a closed circle because there's an equals to bar. And the shading will be everything in between these two because x is sandwiched in between 12 and -10. That would be what our graph would look like. Why don't you guys pause the video and write down what the interval notation would look like? Okay, so let's check our interval notation. So our interval notation will go from 10 to 12 with a parenthesis at -10 to 12 with a parenthesis at -10 because of the open circle and a bracket at 12 because of the closed circle. That is an example of an AND compound inequality. Let's look at an OR. So an OR one is kind of obvious because it has the word OR in it. So this says x less than -2 or x is bigger than or equal to 4. So here's our OR example. Our first example. Whoops, that line got a little wonky. That's a little bit better. So on here, when I go to graph this, I have -2 and 4. Because I have this OR statement, it's not possible to be both of them at the same time. That's what makes it an OR statement. So I have one piece where x is less than -2. So at -2 then, will I have an open or a closed circle? I will have an open circle because there's no equal to bar. And am I going to shade to the left or to the right of -2? I'm going to shade to the left of -2 because it is less than -2. So that's taking care of this first piece on the left. Now for the second statement, it says x greater than or equal to 4. So at 4, will I have an open or a closed circle? I will have a closed circle because of the equals to bar. And then will my shading be to the left or to the right? We will shade to the right because x is bigger than or equal to 4. So I want all of our bigger values. Let's go ahead and write the interval notation as well. And I want you guys to pause the video and do that one on your own first, and then we'll check it together. Okay, let's check our interval notation. Because I have two different branches of this graph, I need to have two different interval notations. So for the section on the left, we're going from -infinity to -2. I'll have a parenthesis at -infinity by definition, and I'll also have a parenthesis at -2 because of the open circle. Or our second one will go from 4 to infinity. I will have a bracket at 4 because of the closed circle, and then a parenthesis at infinity by definition. So we didn't solve either of these. These were just examples already given to us where we can see what an AND statement looks like versus what an OR statement looks like. And we can see for each of them that once they're solved, we would then be able to graph and write the interval notation. And this format of an AND statement always being sandwiched and in between two things will always be true by definition, meaning we'll then only have one interval notation. And an OR statement where they're going opposite directions, kind of like out like two birds flying opposite directions from each other, that will always happen because of the OR concept of being one or the other. And that means I would have two separate interval notations that I'll have to write down. Okay, let's do some actual solvings of these. So our first example says -3 is less than or equal to x minus 4 is less than -1. So what do you guys think? Is this an and statement or an or statement? So this guy is an and statement because they're conjoined together, and I have my x, although it's not isolated, that x is still sandwiched in between two inequalities. We're going to have to first go ahead and solve this before we can graph and do the interval notation. So to solve this guy, it's similar to if I had one inequality like we did in our last learning target. So I would want to add 4, which means I'd have to add 4 over here, and I'd also have to add 4 to the other side. So we really have 3 parts of this, and we want to make sure we keep it balanced. So whatever I do to the center piece, I have to do to each of the outside pieces as well. I can simplify this down. -3 plus 4 gives me 1 is less than or equal to x is less than +3. So we have now solved this compound inequality because x is now isolated in between our two numbers. Why don't you guys go ahead and draw the graph and we'll check it together. So on the graph, I'm going to have 1 and 3. I'm going to want to make sure that I have a closed circle at 1 because of the equals to bar, an open circle at 3 because I'm not including 3, and then the shading would be in between these two because x is sandwiched in between, so x is less than 3 and then bigger than or equal to 1 at the same time. Interval notation for this, why don't you guys pause and write their interval notation and we'll check it. So interval notation will go from 1 to 3. I'll bracket at 1 because of the closed circle, and then an open parenthesis at 3 because of the open circle. Okay. I want you guys to pause the video and do example 4 on your own first, and then we'll check it all together. Okay, let's go ahead and solve this guy. So this is another and statement because although x isn't isolated, it's sandwiched in between. So let's rewrite the problem. It says 7 is greater than -2x plus 3 is greater than or equal to -13. The first thing I need to do is subtract 3. So I'm going to subtract 3 from each piece. So I end up with 4 is greater than -2x is greater than or equal to -16 since I'm subtracting 3. Now from here I have to divide through by a -2. And when I divide through by a negative, remember we have to flip our inequality. And this time I'm going to have to flip both the inequalities because everything is going to get divided through by a -2. So when that happens, we'll end up with -2 is less than x is less than or equal to +8 because a negative divided by a negative is a positive. Let's go ahead and graph this. So when we graph it, we have -2 on the left and then 8 on the right because I should go smaller to bigger. We have an open circle at -2 because there's no equals to bar, and then a closed circle at 8 because of the equals to bar, and then the shading is everything in between since x is both less than 8 and bigger than -2 in between those two values. Our interval notation then would go from -2 to 8 with a parenthesis at -2 because I do not want to include it, and then a bracket at 8 because I want to include that endpoint. One thing I want to point out about and inequalities is when you read them, it should always make sense from one side to the other. So when I started the first problem, I say -3 is less than -1. Well, that makes sense. So then my final answer saying 1 is less than 3 makes sense as well. So if we made a silly arithmetic error as we're solving it, that could be a really nice way that we could check and see, oops, did I accidentally add instead of subtract or do something silly like that. So if we check our second one, it says 7 is bigger than -13, which is why we have greater thans in this case. But because we divided through by a negative, it now makes sense that I have -2 less than 8. So in this example, if we forgot to flip our inequalities, and I got to a final answer that said -2 bigger than 8, I would have to sit there and go, wait, no, hold up a second. -2 is not bigger than 8. Oh, I forgot to flip my inequalities. I divided through by a negative, so I have to remember to flip my inequalities. Subtle things like that can help you check your work as you go throughout the problem, so make sure you're thinking about the whole context of the question and does it logically make sense. Okay, let's look at example 5. So in example 5, do you think this is an and statement or an or statement? So example 5 is an or statement, kind of gives it away by having the word or in the problem. One thing I want to point out, because I've gotten this question before, is an or statement does not mean you solve this one or that one. So we kind of wish maybe it could be, oh, pick your favorite one and solve, but that's not what an or statement means. We will end up solving both of these. It just means that they're two separate and two distinct statements that I cannot combine together. Versus an and statement, I could combine it into be one compound inequality together versus two separate inequalities in an or statement. So we do have to solve both of them. We're just going to start with the first one. So the first one says 3x plus 2 is less than or equal to -7. So to solve this guy, I'm going to subtract 2. So we get 3x is less than or equal to -9. I'll divide through by 3. Because I'm dividing by a positive, my inequality sign does not flip. So I get x is less than or equal to -3. Or now we'll solve the second one. -4x plus 5 is less than 1. I'm going to start by subtracting 5. So I get -4x is less than -4. Now I'm going to divide through by a -4. Will I have to flip my inequality? Yes, I will, since I'm dividing through by a negative. So it will say x is now greater than +1, because -4 divided by -4 will give me a +1. This inequality is now solved, and I have x is less than -3, or x is bigger than +1. Why don't you guys pause the video and graph this on your own first, and then we'll check it together. Okay, so let's check our graph. I have -3 on the left, 1 on the right, since I have to go smaller to bigger. At -3, I have a closed circle because of the equals to bar. And at +1, I have an open circle because there is no equals to bar. A little messy. Let's look at the first one. So these inequalities, I'm going to graph them ultimately separately, just on the same number line. So the first statement says x is less than or equal to -3. So when I'm looking at -3, I want everything that is less than, so everything to the left then. For the other inequality, it says x is greater than 1. So from 1, I want everything that is bigger than it, so everything to the right. And we want to make sure, remember, since this is an or statement, we know our graph should look like this. I should have two separate pieces going in opposite directions. So if we were solving these, and let's say we made the common mistake of forgetting to flip our inequality, then when I went to graph it, it could help remind me. So if I forgot to flip my inequality, let's say I said this said x is less than +1, the issue with that is not only I forgot to flip the inequality, but when I go to graph it then, the graph from 1 would be going to the left-hand side, which that wouldn't make sense in an or statement. They should be going opposite ways. So if we make those silly errors, we have a way to check our answer so we know, oops, I forgot to flip the inequality. So let me go back, flip it, so it should say x is greater than 1, which makes sense then why it's shading to the right, because I knew it was supposed to shade to the right. So silly things like that, you can help check your work as you go throughout them, so just make sure you're slowing down and thinking back through the process. Okay, let's look at how can I do the interval notation. Why don't you guys pause the video and try the interval notation on your own first. Because I have two parts of this graph, I need two interval notations. On the left-hand piece, I'm going from -∞ to -3, parenthesis at -∞ by definition, a bracket at -3 because of the closed circle. Then for the second part, I'm going from 1 all the way to infinity, parenthesis at 1 because of the open circle, and a parenthesis on infinity by definition. Okay, we have one last example in this section. I want you guys to pause the video and do example 6 all on your own first, and then we'll check it together. Okay, let's check example 6. So we do have an or statement, kind of gave it away for us with that word in there. So I have negative 3x plus 1 less than or equal to negative 29, or 2x minus 3 is less than 7. From here, let's just solve these one at a time. So I'm going to take the first one on the left side. I'll have to subtract 1, so we get 3x is less than or equal to negative 30. From here, I'm going to divide through by a negative 3. So I'll have x is greater than or equal to positive 10. Because I divided through by a negative, I have to remember to flip that inequality. So I have x is greater than or equal to now. So we solved the first one. Now let's go solve the second guy. I'll add 3 and get 2x is less than 10. Divide through by 2. Because I'm dividing through by a positive, the inequality sign will stay, and I'll get x is less than 5. And I have now solved both of our inequalities. Our next piece left to do is to go ahead and graph it. So I need both numbers on here, and it's really tempting to want to say, oh, I got 10 and 5, because we're so used to doing the first and then the second. But on a number line, 10 is bigger than 5, so I got to flip-flop those around. That's why you want to pay close attention. So I should have 5 and then the 10, just so that I'm going smaller to bigger. Let's start with the x is greater than or equal to 10. I'll have a closed circle because of the equals to bar, and I'll be shading to the right because it's bigger than or equal to it. And on the second one, it says x is less than 5, so I'll have an open circle because of the less than, and I'm shading to the left because I want everything smaller than it. This makes sense that I have 2 going out in opposite directions since it is that or statement. Now for our interval notation, I have negative infinity to 5 for the first piece. I'll have a parenthesis on negative infinity and a parenthesis on 5. And then the second piece, we're going 10 to infinity. I'll have a bracket on 10 and then a parenthesis on infinity. And we have finished off our last example in learning target 3B. So we talked about how to write an interval notation at the beginning portion of this video, and then we went through what are compound inequalities and how to solve a bunch of and or statements.